Let's look at 2024 AMC 10A problem 14. One side of an equilateral triangle of height 24 lies on line L. A circle of radius 12 is tangent to line L and is externally tangent to the triangle. The area of the region exterior to the triangle and the circle and bounded by the triangle, the circle, and line L can be written as a times root b minus c times pi, where a, b, and c are positive integers, and b is not divisible by the square of any prime. What is a plus b plus c? This is clearly a geometry problem. And to solve any geometry problem, let's just first draw a graph. So we have an equilateral triangle of height 24 that lies on line L. So let's draw a line first. Alright, so this is like just some random straight line here. And then we have an equilateral triangle on this line, right? So 60 degrees. That should be about it. And the height is 24, so we know that this thing here is 24. And then the circle of radius 12 is tangent to line L and is externally tangent to the triangle. So let's say the circle is on the right side of the equilateral triangle. So the radius is 12, so the diameter is 24, so the circle would be somewhat like, let's see. Let's just sketch this out really quickly. The circle would be somewhat like this. Yeah. Okay, that would be our circle, right? It might not be really accurate, but it is a circle, as we can probably tell. And then, what are we trying to figure out here? We're trying to figure out the area exterior to the triangle, so outside of this triangle, and outside of the circle, and bounded by line L. So basically we're trying to figure out this area over here. Oh, my bad. That area right there. And how do we do this? Well, this is like an area where there's no formula for, right? Because it's like there's a curve and there's two lines. It's not a triangle or a circle or a sector or anything. So what you want to do is maybe find areas for like something bigger and then subtract it from something else and then get this remaining piece. So what does that look like? If we connect these two radii, because whenever you have tangent lines in an AMC problem, you want to connect the center to these tangent points, these points of tangency. Then realize that the area of the blue thing, whatever it is for now, minus the area of the orange sector here, part of the circle, will be our answer. So how do we find the area of both of these? Well, we can draw another line and split this in the middle. And we get two triangles. So 2 triangles minus a sector. That's not that hard, right? So we know from the basically kind of definition type of property of a tangent line that the radii are perpendicular to these lines. So we have 2 right triangles, and we can also prove these 2 right triangles are congruent because we can use HL. So these 2 sides are equal because they are the radii. This side is equal to this side because, well, yeah, something is equal to itself. So it's HL. So these 2 triangles are congruent. So that makes life actually a lot easier. Firstly, we know that the circle has radius 12, so these 2 sides are both 12. Then we only need to find this side, right? Because base times height divided by 2 is area. So how do we find the base of these 2 triangles? Well, let's see. We know that this is an equilateral triangle and this is 60 degrees. And since these 2 angles are equal because of being congruent triangles, these two angles are also 60 degrees. So that makes life a whole lot easier. We have a 30, 60, 90 triangle, or we have two of them. And if this side is 12, then the base would be 12 divided by root 3, which is, wait, let me see. Wait, so 12 divided by root 3 would be 4 root 3. Okay, so the base is 4 root 3. And that means the area of these two triangles would be 1/2 would be 2, because there's two triangles, times 1/2 times base times height. And that gives us 48 root 3. Okay, now finding the area of the sector, which is so much more easier because we already have the angles. This is 60 degrees. So the area of the sector is just 1/6 of the area of the entire circle, which is pi r squared, pi 12 squared. 144 divided by 6 is 24. So that's 24 pi. So our answer would be 48 root 3 minus 24 pi. Now what's a plus b plus c? That's 48 plus 3 plus 24. Which gives us 48 plus 24 is 72, 75. And the answer is D.